In this video, what we're going to be focusing on is the intersection of two lines anywhere within our general system. Now, up to this point, we've looked at certain scenarios involving lines that intersect with various properties. So we've looked at bisectors, perpendicular bisectors, altitudes of triangles. What we're going to be looking at now is if I have two general lines somewhere in an environment, so a line there and a line there, what we're going to be looking at is calculating where those two lines intersect each other, so where they meet and where they cross. Now, there are three techniques that we can use in order to do this. What to do is you pick the one which is most useful to yourself, which you understand the best, and which is the easiest for you to comprehend. The first technique is something called elimination. Think of this one as very similar to solving simultaneous equations. Now, we did simultaneous equations back in National 5, so this technique, when you see it, should be the one that instantly resonates with a lot of people and instantly makes you think, oh, yep, that's not a problem. The second step and the second type of technique is something called equating. Now, when we are equating, what that basically means is we are changing the subject of both equations to the same variable, so the x's or the y's, and what we then do is set them equal to each other and solve for that variable. Once we've solved for that variable, we then substitute back in to find the other. And our third actually stems on from that, and that one is called substitution. Now, what we do for this one is we pick one of the two equations and we change the subject and make it x or y within that equation, and we then take it and substitute it into the second equation for that variable. Now, regardless of which of the three techniques we use, ultimately we're looking for the same thing. What we're looking to get is a solution for x and a solution for y that gives us a coordinate. Now, that coordinate tells us where the two lines meet. What we're going to do is I'm going to take an example and I'm going to show you how you solve it with each of the three techniques. But what that's also going to indicate is it doesn't matter which technique we use, we should get the same solution regardless. So the first technique that we talked about there was a technique of elimination. Now, for the three examples I'm going to look at, imagine I've given you two equations of lines. So I'm going to take one, and I'm going to tell you that I've got the line where the equation is given by 3y equals x plus 15. And I'm going to give you a second line where y equals x minus 3. So they're the two solutions I've got. Now, the process of elimination, we have to think of it as being very, very similar to simultaneous equations. So we set up the system where we've got 3y equals x plus 15 and y equals x minus 3 below it. Now, what we're looking to do is eliminate one of these variables and solve for the other, and we can then substitute back in to find the second variable. So we're looking to get the coefficients of one of the two of them equal to each other. Coefficients of the y's are not equal to each other, but in this case, the coefficients of both x's are 1. Now, if they weren't, I could pick either of the two variables to eliminate. But because the x's are the same, I can simply say to myself, right, I'm going to treat it exactly like I would a chimney sum and substitute and subtract the second equation from the first equation. So I'll do 3y take away y, gives me 2y. X minus x gives me nothing. 15 take away negative 3 minus minus becomes a plus. 15 plus 3 gives me 18. So I know that 2y is equal to 18, so from that, I can then find that y equals 9. Now that I know y, I can go back and substitute it into either of these two equations to find out what the x is. Now, hint at this point, pick the easier of the two, so I'm going to pick the bottom one. From that, I could simply say that 9 equals x minus 3, solve that, and I get that x equals 12. Now, we're not done at this point because we want the coordinate where it meets, not just an x and a y value. So what we then have to say is that the two lines meet at the coordinate, and in this case it would be 12, 9. So solving it by elimination, we do the exact same set of steps we would if it was a pair of simultaneous equations, and we get our answer. Imagine we then went to the second technique. So our second technique was the process of equating. So what that meant was changing the subject of both equations to being the same thing and then solving them from there. So again, our two equations, we had 3y equals x plus 15, and we had y equals x minus 3. Now, the y in these cases has a different coefficient, but the x has the same one. So let's take both equations and change the subject of the equation to be x. So in this case, I would take the first equation and make it subject x by shifting the 15, and I'd get x equals 3y take away 15. And this one, I'd make x the subject of this equation by shifting the 3 over, and I get x equals y plus 3. So I've got two equations with the subject as x. I now equate them to one another, and I say 3y minus 15 equals y plus 3. And we solve it like we would a normal equation. Subtract y from both sides, and I get 2y. And to eliminate the minus 15, I add 15 across. So I get 2y equals 18, y equals 9. And again, at this point, we take the 9 and substitute it into either of these two equations to get our value for x. And again, same hint as last time, pick the easier one to work with, which in this case is x equals y plus 3. So I know that x equals 9 plus 3, so it's 12. And again, don't just leave it like that, put it back in the context. We want a coordinate where they meet. So what we want to say is that they meet at the point 12, 9. Again, we've got the same answer as the first one. So we've used two different techniques and we've got the same answer. Just showing that it doesn't matter what technique we use as long as we pick the one we're most comfortable with. So now that we've shown that with these two techniques, if we were to look at the third one, we'd hope to get the exact same answer of 12, 9. Let's have a look at that. So our third technique, if we remember, was called substitution. What this meant was taking one of the equations, setting it to being one of our variables and substituting it into the second equation. So imagine we had 3y equals x plus 15, so that was our first equation, and we had y equals x minus 3. Now, of the two of these, you'll notice that for the second one, I've actually already got y as the subject, so it makes more sense to take this one and substitute it in place of the y in this one, solve it for x, and then substitute the x back in at the end. So let's do that. So I'm going to substitute the y in there for the y in that one. So I'd have 3 bracket x minus 3 equals x plus 15. Once I've got this, it's a case of simple algebra to solve the equation. Multiply the brackets, and I get 3x minus 9 equals x plus 15, and then solve it as we would. Take the x across here, and I get 2x. Add the 9 onto this side. 2x equals 24. So if 2x is 24, that means that x equals 12. We can then take this value for x and substitute it back into either of these two equations. Again, think along the lines of picking the easiest one, this one right there. I know then that y equals 12 minus 3, y is equal to 9. Again, finish it properly. Put it back in context. So in this case, I'd have to say that they meet at the point 12, 9. So I've got three different techniques there. All three techniques have yielded the same answer. They've given me the coordinate 12, 9 as the point where the two lines intersect each other and where they meet. When we're working with this sort of question, it doesn't matter which of the three techniques we use. If the question specifically states one, we have to use it. But if it doesn't, we pick the technique we're most comfortable with. We pick the one that resonates with us the best, that we understand the best, and we can work through clearly, ensuring we get that answer that we require at the end. Now, there's another video coming up which is going to work you through a big example of this, bringing in a lot of the straight line stuff we've come together with and this technique here. Good luck.